All right, so we'll go ahead and get started with problem number one. The data below represents the actual high temperature for 14 consecutive days. Use the temperatures to construct a STEM plot. Okay, so here's the data set, and we want to construct a STEM plot or STEM and link plot for this. And if you recall, what a STEM plot is, if you recall what a stem plot is, it's going to be this. I'll have a vertical line like this. The stems are going to be the first digits. The last digit would be your leaves. So based on this, the lowest stem that I'm going to have to use is going to be for the 50s. So I'm going to start with the 5, and then 6, 7, and then 8. Because I think the largest number there is 87. And then we list their leaves here. And you should have 14 leaves here on the right side of that vertical bar. So for the 50s, I have 59, 52, 50, and 58. So what goes first is the 50. We put those in numerical order. The leaves go in numerical order. So it'll be a 0 to represent 50. And then 52 is next. The 2 goes there. And then 58. And then 59. So those are my leaves for the 50s, 50, 52, 58, and 59. Now for the 60s, are there any numbers in the 60s? There's only one, which is 67. So the 7 will go here. All right, and now for the 70s. For the 70s. I got 72, 77, 71, and 78. So 71 goes first. And then 72, 77, 78. And then for the 80s, well, I got 85 twice, 81, 80, and 87. So let's see, the 80 goes first and then 81. Notice I got 285, so I need to write down the stem of 5 twice because I have to account for every single data value, and then 87. The 7 goes last. And you want to count up your stems to see if you have 14 data values here or 14 leaves. Otherwise, you missed a data value somewhere. That's 5, 9, 14. So that is the stem plot for this data set. Are there any questions about problem number one? All right, number two. Students participate in an experiment to test their ability to determine when 1 minute or 60 seconds has passed. The results are given below. And here you want to find the following: the mean, median, mode, mid, range, variance, and standard deviation. So in problem number two, first of all, let's put these data values in numerical order. So the smallest number would be, should be 52, then 53, 57, 66, 69. So here I'm putting these data values in numerical order from least to greatest. And then in part A, we need to evaluate or calculate the mean. And of course, the mean, which is x bar, that's the sum of all your x's divided by the number of data values that you have. So that means I'm going to take 52, 53, 57, 66, 69, divide that by n. How many data values do I have? 5. Now, if I take the sum of those 5 numbers in that numerator, what would I get? Or what should I get? $297. And 297, divide that by 5, you're going to get 59.4. So the mean there will be 59.4. Now, part B is finding the median. And the reason why I put these data values in numerical order is because I want to find out what the median is. To find that out, you have to first arrange the data set in numerical order and find the middle number. And if there are 2 middle numbers, then you're going to take the average of those 2 middle numbers to get your median. So what would be the median here? 57. Okay. Because that's the middle number, as you can see. Questions on part B. Part C is identifying the mode. The mode is the data value that occurs the most frequent. There is none. Each data value occurs only once, so that means that there is no mode. So you can just say none for that. And then for the mid-range, of course, and I'll write this out as the highest data value plus the lowest data value. That sum is divided by 2. So what's the highest data value in this set? 69. And what would be the lowest? 52. Now add 69 and 52 together, you'll get 69 and 52 will give us 121. And 121 divided by 2 would give us 60.5. So the mid-range of this data set is 60.5. Okay. Part E is finding the range of the data set. That's simply the highest data value minus the lowest data value. So in this case here, the highest data value is 69 minus 52. That's the lowest, which is 17. So the range of that data set is 17. Okay. Part E is the range. Part F is the variance. Now this is where you have to do the x, and then you have to do x squared. And there's a formula for finding the variance. Let's see, I'll go ahead and write down what those x values are. And here with the variance, these data values don't have to be in any numerical order. And we also found out that the sum of my x values is 297. We found that out to be that. Now we just have to square each one of these data values. So if we square 52, that's 52 times 52, that would be 2,704. Square the 53, you'll get, should get, yeah. And then 57 squared would be maybe what, 3,249? And then 66 squared is 4,356. And then finally 69 squared will be 4,761. Now to get the sum of these x squares, we just add those 5 numbers together. So Add 2704, 2809, 3249, 4356, and 4761, you'll get 17,879. Okay. Now, our n is 5. That's the number of data values that we have. The formula for finding the variance is this. S is equal to n times the sum of all your x squares minus the sum of the x's, and that's going to be squared, all divided by n times n minus 1. And this is one of the formulas that will be on the formula sheet as well that I'll provide for you on the final exam. Now the n, that's the number of data values, that's 5, times the sum of the x squares. We found this out to be 17,879 minus the sum of the x, that's 297, but that 297 will be squared, divided by n, which is 5, times n again, that's 5 minus 1. And what I would do here is do the numerator and the denominator separately on the calculator. So in this case here, if I do 5 times 879 minus 297, and that's squared, that numerator will be 1186. And I think I can do this mentally. 5 minus 1 will be 4 times this 5 out in front will be 20. So I have 1186 divided by 20. That variance, or S squared, would be 59.3. So the variance of this data set is 59.3. And then part G is finding the standard deviation, which is, of course, lowercase s. And to find the standard deviation, you take the square root of the variance. So if I take the square root of 59.3, second x squared for the square root, 59.3. If I was to round that off to one decimal place, what would that be? 7.7. So the standard deviation there will be 7.7. Okay. Are there any questions about problem number 2 and how that's done? Okay, problem number 3. In a pre-algebra classroom, there are 11 boys and 4 of them are blonde. Also, there are 14 girls and 6 of them are blonde. What is the probability that a girl or a blonde child will be selected at random? Okay. That's one of those addition rules in probability that we talked about. So if I want to find the probability of a girl or a blonde, so the probability of A or B would be this. The probability of event A plus the probability of event B, and then we have to subtract off the overlap. We have to subtract off the overlap with OR. Probability of A and B. Because if you look at that table, you have the girl and then you got blonde. those two intersect. They have something in common. So we have to subtract off that overlap. So if I was to write this out, this would be the probability of a girl plus the probability of blonde, and then subtract out the probability of a girl and who's blonde. Now, let's see here. From this table, how many girls are there? How many girls total? 14, and the grand total is 25. So the probability of selecting a girl would be 14 over 25 plus, let's see, how many blonde people do I have total? 10 out of 25. So add to it 10 over 25. But I got to subtract off that overlap. And to show the overlap, that's the probability of a girl, the probability of a blonde. Where does the overlap occur? What number? 6. Okay, because you got 6 girls and a blonde here, so I subtract 6 over 25. And that is to prevent double counting. So if I know the denominator is 25, so I just bring that down. What's 14 plus 10 minus 6? 18. So the probability of selecting a girl or a blonde child will be 18 out of 25. And if you were to write this out as a decimal, that would be what? It's 18 divided by 25. 0.72. So the probability would, as a decimal, would be 0.72. All right, questions on problem number 3. All right, now problem number 4 is one of those combinations and permutations problem. This one's a combination problem. And it says here, find the probability of winning a lottery in which one selects the 6 winning numbers from 1 to 22 in any order with no repetitions. So we got 22 numbers. We're selecting 6 of them in any order. So it'll be 22C6. Now, the way we enter that in the calculator would be this. Let me see here. First of all, let me clear this out. First of all, we enter the number on the left-hand side, which is your 22. And then we press this math key, go over to PRB for probability using your right arrow key. It's a combinations problem, so that means we have to use menu item number 3, NCR. So make sure you enter the number on the left side of the C in first, and then math, PRB, NCR, number 3. And then enter your second number behind it. That's the 6. And then hit enter. So NCR, the number is 74,613. But here we want the probability of winning. There's only one way you can win it, so it's got to be 1 over this number right here, 74,613, and I will leave this as a fraction. I don't care about the decimal. I'll leave that as a fraction. Okay. Any questions about problem number 4? Okay, we'll stop right here. The remaining 8 the remaining 8 I will do on Wednesday. Okay. And let me